No.
It's hard to listen. So hard to listen. That's on.
Here's my post. It goes like super in the back.
Awesome.
Wow, okay.
You would go.
Now in here, are they like chapter 2 to spring here? How do you do that? Oh my gosh, I'm in trouble with these note sheets. It's the best for you.
Oh, that's right. Oh.
I love it. These are
No, they're off.
Yeah, that's what I like. Also, my nails look like that into like a t-shirt. I should take that.
Don't be serious.
I will share.
Okay, guys. You should have found that your grades have been posted since yesterday in Blackboard. You can also find them in my math lab. If you look in my math lab, you may see two different grades. One's going to say just Chapter 2 grades. And it does say omitted with that, but that's so that you can go back in there and see which ones you got correct and which ones you made a mistake on, so you can see your work. And then the official final grade, which incorporated the review that you did, that would be called Chapter 2 final test grade. So that's the actual grade that gets averaged in there that incorporated your review. Trying to think, are there some basic things? I know I'm saying this to people who aren't here, but in general, if you are here, if you're not here, you're still responsible for any homework, information, announcements that is given. So if you're not here, still make sure that you are up to date with anything that happened in class. Second of all, there will be no more, Miss Sadler, can you give me an extension on my homework? Because when I assign homework, it's expected to be done by the next class period. You still have 5 to 7 days to get that work done. So after you make it to the next class period, you're already running on extra time. Okay, so I've built into that extra time for you. So don't wait until the night that it's due, because by then you're already late anyway. So technically it was due 5 days earlier. So no more extensions. Do your stuff early like you're supposed to. Any questions about anything? Okay, so the grade that's in my math lab incorporated your review. And if you were diligent with your review, you'll see that it did help you immensely. Okay, so it helped you have some buffer there. So as we're going along in the course, I'm trying to kind of wean you in the direction of getting used to taking that test on the computer, because that's the way your final, will be. So I've kind of given you some training wheels each time, but each time I'll kind of lessen that a little bit. So get comfortable, get back in there, look at whatever you made mistakes on, so that maybe you won't make those same kind of mistakes next time. Okay? Yes.
Is okra cake supposed to be here?
I don't remember if Okra Coke was not going to be here Monday, or if I don't know.
Okay.
I've had
We're
several.
here. Did you not see us? Okay. Yeah, this okra cake. It's Madam Mesquite. I'm sorry.
Oh, okay. Yeah, I knew Madam Mesquite wasn't going to be here.
I mixed them up.
Okay. You were just mixed up. You're good.
Yeah. We're just seeing if you're paying attention.
Okay. Yay! It's Friday. Let us trudge on. Okay. Today we're starting Chapter 3. And these are quadratic functions. And I will say that if on your last test, if you still, after the benefits of the review, if on the last test you were still in the 60s or below, you really need to evaluate either the way you're studying or what you're understanding, you need to get in touch with me if you need help. If you still did that on the last test, okay? All right. Okay, so let's go to quadratic functions now. Quadratic functions can be written in the form ax squared plus bx plus c, where a is not equal to 0, and a, b, and c are real numbers. So remember, a can't be 0 because if it is, then there's no x squared, so it's not a quadratic anymore. So a, b, and c, remember this means is an element of, that little symbol right there is an element of the real numbers. Sometimes you'll see the quadratic written in the form I have here, but then sometimes you'll see it written in vertex form, which would look like a times x minus h squared plus k. And when it's written in this form, h comma k is called the vertex, and we'll talk more about that in just a few minutes. One thing that is true for either method or situation that you have here is that if the a is greater than 0, we're going to say that that opens up. Now remember, back in our previous chapter, we wanted to memorize what y equals x squared looks like. And remember, that was a parabola that went up. So that would be a situation where your a would be positive. Your parabola goes up. If a is less than 0, if it's negative, then it's going to open down. So the first one would have a parabola opening up. The second one would have a parabola opening down. We're also going to have something called the axis of symmetry as we graph these. And so notice that with the parabola, it's a U, it's symmetric. I could cut it right down the middle, right through its vertex, the smallest point here or the tallest point there. I could split it, and that's what the axis of symmetry is. And that axis of symmetry is a vertical line. And remember, we learned that vertical lines have a special equation, and that would be x equals h, where h is the x coordinate of the vertex. So they're going to be asking us these types of questions. One other question that they may ask us is if they just give you an equation, they may just say, hey, looking at that equation, can you tell me what the vertex is going to be? And when it's given to you in vertex form, it's easy to see. But when it's ax squared plus bx plus c, what you can do is to find the x coordinate of the vertex, you just use minus b over 2a, and that's going to give you the x coordinate of your vertex. And then you can just plug that in to find the y that goes with it. We're going to do examples of all of these, but I just want you to have that information in your notes first. If you want to graph a parabola, what you'll want to do is find the vertex, and you'll plot that, and then you're going to find a point to the left and a point to the right of the vertex, and then you can just draw your U, whether it's up or whether it's down. So here's our first example. remember that f of x is just another way to say y. So I could have said y equals that. It's just another way. So I have f of x equals x squared minus 4x minus 2. So because I see the x squared, I know I have a quadratic, which means if I graph it, it's a parabola. It looks like a U. It's either going to go up or down. Just talking about things, what is the value of A here? 1. What's the value of B? And C? Negative 2. That's right. So our A is positive, right? So I know that when I graph this, it should be a parabola that's going up, right? So I know that piece of information. So if I'm going to graph this, it says first I need to find the vertex. And if I want the x-coordinate of the vertex, I'm going to use minus b over 2a. So this is the x-coordinate of my vertex. So negative b is going to be negative a negative 4 over 2 times 1, which is 4 over 2, which is 2. So that's the x-coordinate. Yes?
Would it be negative 2 because it's a negative 2 times 1?
All right, negative b, so this is that negative, and then there's my b, right? So that gives me
I thought it was CA, not 2.
Oh, okay, 2a, that's okay, yes, 2a. All right, so it is a positive 2, and then I need to find the y that's going to go with that. So what you do is you just go to the original equation, and wherever you see an x, you plug in a 2. So to get the y that I need, I'm going to have 2 squared minus 4 times 2 minus 2. And that's 4 minus 8 minus 2. What did y'all get? Negative 6. So my vertex would be at 2, negative 6. That's my vertex. So that was step 1. Step 2 is I just need to find a point on the left and a point on the right of that vertex. So I make a little T-table where I'm going to choose points. And when you're thinking about going to the left and thinking about going to the right, you're doing it in terms of x. All right, so I'm thinking about the number 2, and I want to choose a point to the left of the number 2 and a point to the right of the number 2. I chose 0 because it's easy. And if you plug 0, into this function, it's going to make a bunch of those terms go to 0, which is going to be very easy to work with. So I would have, when I'm doing 0, I would have 0 squared minus 4 times 0 minus 2. So that's going to give me a negative 2. Now, one thing that is nice about parabolas is they are symmetric with respect to their vertex. So if I'm at 2 and I go over 2 places to get to 0, right, and get a negative 2, then if I go 2 places to the right, what number is that going to put me on? 4. Since it's symmetric, what answer should I get when I plug in 4? I should get the same answer of a negative 2. So if I plug in 4, I'm going to have 4 squared minus 4 times 4 minus 2. And I'll also get a negative 2. Okay? Think about the vertex. I went the same distance to the left as I did to the right, so they should have the same y values. You're going to use these 3 points, the vertex and those 2 side points, to graph. So my vertex, graph your vertex first. That was at 2, negative 6. And then my other points were 0, negative 2, and 4, negative 2. And make sure that you draw a smooth curve and not a V, because a sharp V is absolute value. So this is a parabola, so we have a curve. So that's our parabola. Let's answer some questions about our parabola. We already said that it opens up, right? And we knew that because A was greater than 0, because our A was 1. Another thing that you'll be asked is, tell me what the axis of symmetry is. And instead of writing the words axis of symmetry, I'm writing AOS, but that stands for axis of symmetry. That's the line that cuts right down the middle that makes it symmetric, where the left-hand side looks exactly like the right-hand side. So axis of symmetry, remember, is a vertical line, so it has the equation x equals some number. Remember, for the axis of symmetry, it's going to cut right through the vertex. I'll make it a different color. It would have to be the line that cuts right through that vertex. That's my axis of symmetry. Remember, my vertex is at 2, -6. So what is the x value there? 2. And so my axis of symmetry will be x equals 2. So that's what I would write down for axis of symmetry. The other questions they may ask me is domain and range. Domain, remember, is what x values are used. So you're looking all the way to the left and all the way to the right. So for a parabola that opens up or down, what's my domain? All real numbers. So negative infinity to positive infinity. For your range, you're thinking y values. All right, you're looking up and down. You always go to the lowest first. Well, the lowest it ever is, in this case, is its vertex. Range talks about y values. So the lowest y value that's ever used is what value? -6. And that -6 is included. And then it goes up forever. So that's my range. Okay. Any questions with that particular example? All right, here's another example. It's g of x is equal to -1/2 x squared. G of x could be f of x. It could be y again. It's just the name of a function. Because I see that it has an x squared, I know that I'm dealing with a parabola here. Will this parabola open up or open down? It's going to open down. This will open down. Let's remind ourselves, what is the value of a here? -1/2. What's the value of b? There's no b, so it's 0. And then what's the value of c? It's also 0. Right? So I know that it opens down. Let's find the vertex. All right, so to find the vertex, the x-coordinate of the vertex is going to use -b over 2a. So remember, this is just like using the quadratic formula. It's very good to go over to the side and just write down your values of a, b, and c. Okay? And so I'm going to have 0 on top and 2 times -1/2 on the bottom, but that doesn't matter because 0 is on top. My answer will be 0 for my x value for my coordinate. And then to find the y value that corresponds with that x value, I just plug in 0 wherever I see an x. And that's also going to give me 0. So my vertex will be at 0, 0. What will my axis of symmetry be? Okay, I agree with your 0, but I'm going to be really particular and say if I'm asking for axis of symmetry, I'm telling me, tell me the equation. Yes, x equals 0 is the axis of symmetry. We can go ahead and answer domain and range because we know that this opens down. So you're thinking in your mind, you have a picture like this, the vertex here is at 0, 0. So you could even go ahead and answer that. But we'll graph it first, okay, and then we'll answer domain and range. So we'll make our little t-table. Remember, we have a vertex at 0, 0, just to remind ourselves. And then we want to go, you can go to the left as many places as you want, but, you know, be nice to yourself. I just went to the left and chose a -1. All right, so that means I'm going to plug in a -1 and see what value I get for y. So when you plug in a -1, you'll have -1 squared, and then you multiply that by a -1/2, and you're going to get -1/2. So if I went one place to the left and got a -1/2, then if I go back to the vertex and go one place to the right, what answer should I get? I should also get a -1/2. So I should get a -1/2 because I went the same distance away. That's just something you can learn and know, but you can always plug it in and spit it out. Okay, that will always work. So let's plot these points. I've got 0, 0, and then -1, 1/2, and 1, 1/2. So -1, -1/2, 1/2, and then graph here. So there's my parabola. What is my domain? All real numbers. And what is my range? -infinity to 0. That's right, because you always start at the lowest first, and it's going down forever. So -infinity to 0. That's right. So these first two have been what you would consider standard form. And then the next one is going to be given to you in vertex form, where you don't even have to do minus b over 2a. If you're just aware of the formula, you can pull out your value for the vertex. Now they use a capital F to call this function f of x. There's nothing special about the fact that it's a capital F. They could have used any letter they wanted to. That's just what they chose. When I look at this, I couldn't just look right here and tell you the values for B or C, but I can tell you the value for A, because remember that was true in our vertex form. What is the value of A here? -1/2. So I can't just pull out B and C. But remember our form, y is equal to a times x minus h squared plus k, and it was the h comma k that was my vertex. So when you go inside those parentheses, okay, notice I'm going inside here, and that says x minus h, but yet I said that h was my vertex. You take the opposite of what you see from the inside, but you're going to keep what you see on the outside. So when I want to write down my vertex, the x coordinate is going to be a positive 4. See, it says x minus 4, but I'm going to say that the x I need is 4. And then my k is going to be the 3. That's going to be the number that you do see. Okay, just remember when you go inside, you take the opposite of what you see. So my vertex will be at 4, 3. What is my axis of symmetry? Okay, x equals 4. Yes, x equals 4. Right, and then to graph this, you know you have your vertex at 4, 3. So you just want to choose an x value to the left of 4 and an x value to the right of 4. And I chose the numbers 2 and 6. So if I'm thinking about the number 4, I'm going 2 places to the left to get me at 2, and then I'm going 2 places to the right to put me at 6. You do not have to be symmetric in the way that you choose your numbers. It's another way to check yourself, because if I go 2 units to the left, I should get the same answer as if I go 2 units to the right. So it's like a way for me to make sure I haven't made a mistake somewhere. So if x is going to be 2, you just go back to the original problem, and wherever you see an x, you put in the number 2. So for us, we would have y is equal to -1/2 times 2 minus 4 squared plus 3. Use your order of operations. Do what's inside those parentheses first. So that's going to be 2 minus 4, which is a -2. Square it, right? Get 4. Then you're going to have 4 times negative 1/2, and then add 3. So when I did all of that, I got the number 1. And that's also what you get when you plug in a 6. And then you just plot those points. So I'm at 4, 3, and then at 2, 1, and then at 6, 1. And there's my parabola. Any questions about graphing parabolas? When you use the tool in my math lab, I would suggest that you plot the vertex. First you choose the graphing tool that looks like a U. Okay, first you choose that. Then you're going to choose the vertex and then plot your second point, and it'll automatically make it symmetric. Okay, so that's how that works. All right, so to find any x-intercepts, just like you do when there are lines, the x-intercept is where that graph crosses the x-axis. That happens when y is equal to 0. So if I want to find the x-intercepts of this particular equation, then I let y be equal to 0. And remember, f of x is another way to say y. This is a quadratic set equal to 0. So you're either going to factor it or use the quadratic formula. Okay, this will not factor. So I'm going to have to use the quadratic formula. So take your 5 seconds that it takes to write down your A, your B, and your C, and then use your quadratic formula. So that's minus B plus or minus the square root of B squared minus 4AC all over 2A. This is going to give me negative 4 plus or minus the square root of a negative 24 over 4. Okay, got a problem, right? Because I have a square root and I have negative numbers inside. We learned way back in chapter 1 that when I have negative numbers inside of a square root, if I try to pull that negative out, that becomes a what value? Or what is that? Imaginary. Remember that I thing, right? Okay. We're on the XY axis, which is real numbers. I's are complex numbers. They're not the same. So if I have a negative number underneath my radical and I've done everything correctly, that means I do not have any x-intercepts. So because of this, there are no x-intercepts for this particular function. And let's think about that graphically, how maybe I could have figured that out without even trying to do the quadratic formula. You know, here I've got y is equal to, this is my formula, I'm just writing it down again. If I wanted to say, well, what is my vertex? Let's go through and answer those same questions we answered before. To find the vertex, I'm going to do negative b over 2a to find the x-coordinate. So that's negative 4 over 2 times 2, which is negative 4 over 4, which is a negative 1. The y value would be found just by plugging that negative 1 into the original equation. And when you do that, you get the number 3. So my vertex is at negative 1, 3. Does this parabola open up or open down? It opens up, right? So I know it's going to look like that. So if you think about what we've got here, we've got a vertex at negative 1, 3, and it opens up. So you see it would never cross the x-axis. So there wouldn't be any x-intercepts. So two ways you could come up with there are no x-intercepts. Now, since I brought up the point to tell you that if underneath that radical it's negative, there are no x-intercepts, I'm going to give you your three choices here. If b squared minus 4ac, that discriminant, remember that name? If that is positive, right, then I'm going to have two x-intercepts. If it is equal to 0, then what's going to happen is that vertex is going to be sitting on the x-axis, and I will have one x-intercept. In other words, the vertex sits on the x-axis. So there would be one x-intercept. And if it's negative, like the problem we just had, there would be no x-intercepts. Okay, so the three examples would be if it's positive, you would have two x-intercepts. If it's equal to 0, it would just sit right on there and you'd only have one. And then another example would be where it doesn't ever cross it. Any questions about finding x-intercepts? Okay. The next example that I want to do is example 5 in your book, so you can make a note of that this is example 5, so I don't have to write down the little paragraph that goes with it. Again, I've seen this example in our previous chapters. We're going to see it again now, and you're going to see it, if you go to calculus, you're going to see it again in calculus, all right, the same setup. All right, so here you've got this projectile. So for example 5, it says a ball is projected directly upward from an initial height of 100 feet with an initial velocity of 80 feet per second. And so we're going to be dealing with this function, s of t, which is equal to negative 16t squared, plus v sub naught t plus s sub naught. All right, this is our initial velocity. And s sub naught is our initial height. And so usually they might give you this equation, but then they're going to come back and just tell you what the initial velocity is, and they're going to tell you what the initial height is, so that you just put those values in those spots. All right? So when I read the problem, it told me a ball is projected upward from an initial height of 100 feet, so there's my s of naught, with an initial velocity of 80 feet per second. So now I know that the formula I'm going to be working with, my initial velocity was 80, and my initial height was 100. So there, I've got a nice quadratic. All right, so that's my equation that I'm going to be working with. This is the question. After how many seconds does the ball reach its maximum? After how many seconds does the ball reach its maximum height? And then what is the maximum height? Okay, so whenever you know that you are dealing with a quadratic and you have any question about the maximum or minimum in any way, that is code word for the vertex. Because think about what a parabola looks like. If it's like this, the vertex would be the minimum value, right? And if it looks like this, the vertex would be the maximum value. So when you read a question and they say, what's the maximum or what's the minimum, think, I know I'm going to need to find the vertex. All right? So we'll call this one A. Oh, we'll call this A, and we'll call that B. All right, so to answer A, what is the maximum height? So I need to find the vertex. So remember, if I'm given S sub t is equal to negative 16 t squared plus 80t plus 100, the vertex is not given to me in vertex form, so I'm going to use that minus b over 2a. So I'm going to say all right, let me talk to you about notation. In all of our other ones, we've used x's and y's, right? Now in this one, we're using t's and s's. Whoever's inside your equation and things are being done to it, that's like your x. So you see how it says t squared plus 80t? Okay, so t's are like our x's. So when I go to find my vertex, instead of a x comma y, I'm going to think of it as a t comma s. Okay, t's are like your s's, x's, and s are like your y's. All right. So to find the value of t for my vertex, I'm still going to go minus b over 2a. So that would be negative 80 divided by 2 times negative 16. And you get 2.5. That represents t, represents time. All right? So I found the t. Notice that in part A, it said after how many seconds. So I'm looking for a value of t. So I found the value of t that corresponds with the maximum. So after 2.5 seconds, the ball reaches its maximum height, because that's the t value of my vertex. But part B said, tell me what is the maximum height. Again, they use the word maximum height. I'm thinking about the vertex, but now instead of needing the t part of the answer, I need the s part of the answer. So you just go back to the original equation, and wherever you see a t, you put in 2.5. So the s that I need is going to be found from putting in 2.5. And I'll just tell you that that number crunches down to 200 feet. So the maximum height is 200 feet. So also be careful here and make sure that you're using the units. So that's 2.5 seconds and that's 200 feet. So make sure that you are doing that. Okay. Any questions about those first two parts? All right, then it keeps that same scenario and adds questions to it. It says, all right, since you've done that part, then it wants to know for what interval of time is the height of the ball greater than 160 feet? For what interval of time is the height of the ball greater than 160 feet? So they're asking us for time, but they're telling us about height. And they want to know, tell me what time when S, because that's what S represents height, when S is greater than 160 feet. So what I'm going to have here is negative 16t squared plus 80t plus 100. That's our equation. But I need that equation to be greater than 160. So this should look back, once I get this down, this should look back like things we've done before. All right, we have an inequality. It's a quadratic. It's a quadratic inequality. So I still want to get it in reference in terms of 0, right? So I still want to subtract 160 from both sides. So now this is, once I'm at this point, I'm doing previous chapter. Okay, got a quadratic, got it in terms of 0. Another thing that we can do is if we can divide every term by something to make those numbers smaller, I would do that. I can divide here. I'm going to divide by -4 because I don't like my coefficient of t squared to be negative. It just makes it easier to work with if it's not. So this becomes 4t squared minus 20t plus 15. Oops, wrong way. But if you divide by a negative number, remember you have to flip that inequality sign. Then you try to factor this, or you can use the quadratic formula because that always works. So we're going to use the quadratic formula. So A is 4, B is -20, C is 15. So our t is going to be equal to 20 plus or minus the square root of -20 squared minus 4 times A times C all over 2A. It doesn't come out pretty. You still get 2 decimals. When you have 5 plus and divide by 2 and 5 minus divided by 2, the two numbers you're going to get is 0.92 and 4.08. So they are the two answers that you will get. If you take your calculator and say 5 minus the square root of 10 and divide that by 2, you'll get, suppose you would get 0.92. And if you say 5 plus the square root of 10 and divide by 2, you would get the other one. That's still not our answers yet. Remember what we had to do with an inequality? We had to draw this number line. We had to plot these 2 points and split it up into intervals. And then we needed to know which interval made it true. All right? So you choose some test points in each interval. You plug those back in, and you can plug them into any one of these 3 that are listed here. You could plug them into the first one, the second one, or the third one. It doesn't matter. But you just want to know, I think the one in reference to 0 is the easiest because really all I'm trying to figure out is whether it's positive or negative. I don't have to compare it with another number like 160. And so I plug mine into this last one right here. And so, for example, if I'm going to choose 0, if I plug 0 into this last one, I would have 0 minus 0 plus 15, right? Which would be a positive answer. Does that make that true? No, that makes that false. All right, so that makes that false. So remember how it should repeat. Do that. If it's false, then I should have a true, and then I should have a false, right? So that is going to happen with these quadratics. So the only interval that makes this true is the part that's right here in the middle. That's the interval that I want for my answer. So the interval is going to go from 0.92 to 4.08. I used parentheses there because in the original problem, notice it was just greater than. It wasn't greater than or equal to. Okay, if it had the little equals to, then I would use the bracket. So it's above the ground when, or above 160 degrees, when the time is between 0.92 and 4.08 seconds. Okay, so a lot to think about there. A lot of down memory lane because we did that before. And the last part of this says, after how many seconds, and I'll tell you that this is a very good problem. You should see it in your homework, and don't be surprised to see it again on a test. Okay, so make sure you can go through this problem. After how many seconds will the ball hit the ground? The reason why this is a good problem is basically you see it incorporated things we had done in the past. It also makes sure you understand, are they asking for T's? Are they asking for S's? Do you know if T is like an X or S is like a Y? It makes you pull a lot of information in. So the last part here says, after how many seconds will the ball hit the ground? So they're asking us to find T again. But when will the ball hit the ground? It's talking about S, right? What is S when the ball hits the ground? 0. So that's saying, look at your original problem and let S be 0. All right, so 0 equals negative 16t squared plus 80t plus 100. It won't factor. Use the quadratic formula. You could divide everything maybe by, I know at least 2, but maybe by 4. You could divide everything by 4. But I just left it all the same and just said, let me just use my quadratic formula. I have my calculator. It can number crunch big numbers for me. So minus b plus or minus the square root of b squared minus 4ac all over 2a. When I do that, I get 2 values for t, remember, because it's plus minus. The 2 values for t that I get were negative 0.04 and 6.04 seconds. So I get 2 choices, right, of when it's going to hit the ground. Which one doesn't make sense? That's right, the negative one doesn't make sense. Time is not going to be negative, so the only answer I'm going to have is 6.04 seconds. Okay, so after 6.04 seconds, it hits the ground. You do have a homework problem that asks you a question like, find 2 numbers whose product is the maximum possible value. All right? So you're looking for 2 numbers that you can multiply together that will give you a maximum possible value. I'm just going to set this up because if you don't recognize how to set it up, you can't work the problem. You should think right now anyway, since you see maximum in application problems, now you should be thinking, oh, if this is a quadratic, they're really asking me find the vertex, right? So here, before I can find the vertex, I have to find the equation I need to use to find the vertex. They told me I had 2 numbers, and that if I added those 2 numbers together, I would get the number 10. Does anybody have an idea of how to represent those 2 numbers? If I tell you x is the first number, what would the second number be? Y, and to represent y, it would be 10 minus x. That's right. So I'll let x be my first number, and y, which is my second number, would be 10 minus x. That's right. Okay. But remember how I've said a couple of times in this class, if I'm only going to have one equation, how many unknowns can I have? 1. One equation, one unknown. So I can't have x's and y's. I need to be able to write my equation with just x's. Well, remember it said the product. What does product mean to do? Multiply. So I need the product to be a maximum. So I need to multiply x times y to be a maximum. Well, y is 10 minus x. Okay? And I need this to be a maximum. So notice 10x minus x squared is a quadratic, right? That's a quadratic because you got x squared. You can write it in this order if it helps you. The a value is a -1. The b value is 10 and c is nothing, right? So can you find the vertex from this? Minus b over 2a, right? You got your b, you got your a. So you can find minus b over 2a, and that's going to give you your x value, which would be your first number. You just subtract that from 10 to find your second number. Okay, so there is a problem like that in your homework. Okay, so we're starting fresh. Your homework is in my math lab. Remember, it's due by the time I see you Monday. If not, you already have extension period built in, right? So get your homework done. Have a good weekend.